12 Python tips and tricks that you probably didn't know. Number 1. Download YouTube videos with YouTube DL. YouTube DL is a command line tool written completely in Python, and it is very easy to use. You can download any YouTube video in various formats and resolutions with one line of code. You can install YouTube DL using pip, which is Python's package manager. Once installed, you can grab any YouTube link that you want. For example, I'm gonna grab this link over here, and in your terminal or command prompt, you can type YouTube DL and then paste the link inside. This should go ahead and download that YouTube video for you. You can follow the link in the description for YouTube DL's official documentation for all sorts of options which you can pass into this command line to adjust the video's format and resolution. If we check inside the folder, we can see that indeed we have the video downloaded. YouTube DL also has bindings for Python, so you can programmatically trigger or download YouTube videos from inside your Python scripts. So this is a sample Python script for downloading YouTube videos. So first up, you import YouTube DL, and then you have a list of all the links which you want to download. So in this case, I only want to download one video. So I have the link over there, and then we initialize YouTube DL's constructor in this way. And do keep in mind that we can pass in a bunch of options inside this constructor for adjusting the video's quality as well as resolution. And then we can just say ydl.download of links, and this should go ahead and download all the links which you had specified. So in order to run that, we can call Python and then the script name, which is youtube.py. And it should do the exact same thing which we had seen from the command line tool. Launching a fully functional HTTP file server. This trick is really helpful for whenever you want to set up a file server on your laptop or your machine and want it to be accessible over all of your devices on your network. So for example, if I want to set up a file server, I would type this command. Do keep in mind that this command is only for Python 3, and for Python 2 you would have to enter this command. So now as we can see, our HTTP server is running on port 8000. So now if we open up our browser and go to localhost 8000, we can see all the files which are present inside the directory from where we had started our HTTP server. So you can see that we have a youtube.py script which we had earlier written, and we also have the YouTube video which we had just downloaded. Now the cool thing is that this directory listing is accessible over all of your devices on your network. So if you open up your terminal and type in ifconfig, if you are on Mac or Linux, for Windows it is ipconfig, you can find out your local IPv4 address over here. So in my case, it is 192.168.29.98. So if I copy that address and enter it into my handheld device, which is connected on the same network over Wi-Fi, I can indeed see that all of the same files are now accessible over my phone as well. So I find this trick really helpful whenever I want to transfer files from my laptop to multiple devices at the same time wirelessly. So what I've done using this in my home is that I have a Raspberry Pi which I have lying around, and I have connected to it a hard drive which has all of my movie and TV shows collection, and I have started up a similar file server on the Raspberry Pi over my network, and now I can access all of my movies and TV shows on all of my devices wirelessly from wherever I am in the house. Number 3, controlling your browser and its contents from a Python script. So this trick comes in really useful when you want to load websites programmatically on your browser. So we have a very simple script over here, And there is a standard Python library called webbrowser which allows you to do this. So on the first line we import webbrowser and then we define the URL which we would like to visit. So in my case it's some Amazon URL. And then I say webbrowser.open new and then I pass in the URL which I want to open. When we run this, we can see that automatically my web browser opens up and loads up the URL which we had specified. So a good use case for this would be an example where you have a set of 10 websites which you load up every day in the morning as soon as you open up the laptop, but you do it manually. So you can write a quick Python script with all those 10 websites and just fire that up the first thing in the morning and it would load up all of those 10 websites for you. Number 4, schedule your Python jobs to trigger automatically after a certain amount of time. Say you want to schedule a job to be executed for a later time in the day or maybe the week. You can do that using sched, which is a part of the Python standard library, and it is really easy to use as well. So here I have a script which uses that library. So we import sched and we also import time. And this is the function which I want to schedule to be run at a later point in time. So to do that, first I initialize the scheduler object and we pass in the time method and the sleep method from the time standard library, and then we enter that particular job into the queue. So now say I want to run this function over here after 5 seconds. So I can say s.enter 5, meaning that I want that function to be run after 5 seconds. This can be any value. This over here is a priority value, so you can just leave that to be 1 for now. And then the function which you want to be executed, so which is my function over here, and if that function takes any arguments you can specify it over here, but since we don't have any, we can just leave that to be empty, and then we can say s.run. So now when we go over to our terminal and try to run this Python script, we should see hello being printed after 5 seconds. There we go. So this might not seem like much and we can probably just do this with a simple time.sleep of 5, but this is where things get really interesting. Say I want this job to be run after every 5 seconds forever, right? So I can make a small modification to this code, and every time we call our function, we also enter it again in the queue. So now when I run this scheduler will make sure that my function is run every 5 seconds from now till forever, as long as my main Python script is running. Now let's say you want to build an Amazon price checker, right? So say you want to buy a phone and you've been tracking its price every day now, and you want to buy it as soon as it hits a particular low price. So we can take out some code from our web browser example and put it inside the scheduler example which we're working with right now. And this particular line, we'll paste it in over here. Now let's say I want to check this price every 1 minute, right? So I can say 60 seconds over here and 60 seconds over here. And this would make sure that the web browser opens up with that particular Amazon page and I can check the price every 1 minute. So in essence, the web page will be refreshed every 60 seconds automatically so that I can have my eye on the price. So for demonstration purposes, I'll change this back to 5 over here. And let's run this. So it should automatically open up the web browser after 5 seconds with that Amazon link. So I can see that the price is $361, and then it'll keep getting refreshed after every 5 seconds. So you can change that time to be 1 hour, 2 hours, 3 hours, whatever it is, and the scheduler will take care of it. Number 5, requests HTML. To be honest, to repeatedly check the price of some product on Amazon, scheduling a job to open up a web browser every single time is not an efficient way to do it. A much simpler way would be to write a small script which would scrape data from the website and display it to us rather than opening up the entire browser itself. That's where requests HTML comes in. Requests HTML is a HTML parser which allows you to parse content and use it programmatically. To install it, you can use pip, and that should go ahead and download it for you. So I've written a small script here called pricechecker.py, and over here I have imported HTML session from request HTML, and I've initialized the HTML session also. And this is the target URL which I want to scrape the data off of. And we can load that website up by saying session.get and passing in the URL. That would load up the entire website and its HTML and JavaScript content and store it in a variable called r. Now from this entire HTML source, we only want to extract the price of the object, right? So this is the product here for which I want to check the price. And the easiest way to get certain data from a website is by highlighting it and then right clicking it, clicking on inspect element. That should open up the developer tools, and over here this is the element which houses our data. So it's a span tag and it has an ID. ID is price block underscore our price. So we want to grab that ID and we will paste that ID over here, and we'll also add a hash in front of it. So our element ID is hash price block underscore our price. So when we say r.html.find and then pass in that element ID from the entire HTML source of that website, it will find out, or it will obtain only that element which has this ID over here. And when we pass first equal to true, this method will only return the first element in the entire HTML source which has that element ID. After this line of code has done executing, the result would be stored in this variable a, and then we can say print a.text, which should go ahead and print the final value, which is the price of the object. So I can run that code like this, and it says rupees 47,900, which is in fact the price which we have over here. So you can have this script running in the background, constantly checking, say 2 times in a day, 5 times in a day, to notify you whenever the price drops. So you can hook this up into the scheduler script which we had written earlier, and instead of opening up the entire browser itself, we can simply use request HTML to get the price and notify the user. Number 6, adding color to your print statements. This is a really quick and simple one. There's this library called colorama, and using that you can colorize your print statements or whatever you're outputting to the console, be it print statements or logging statements. You can add color to them depending on what they are. So to install this, you can say pip install colorama. So now that Colorama has installed, I have this small script which I have written. So the first one is I'm importing 4 from Colorama. So 4 stands for the foreground color. And then we also import the initializer method from Colorama and then call it over here, which sets everything up. After that, I can add color to all of my print statements like so. So whatever the message is, I can add 4.green before that message to make that message appear in green color. Similarly, I have a yellow color, I have a red color, and I have a blue color as well. And there's a lot of other cool things which you can do using this library as well. You can add background color, you can add styles to the text, etc. So let me quickly run this script over here. And as you can see, we get colorful messages over here. So yeah, this is a small and quick library which adds some splash of color to your console outputs. Number 7, one-liner if-else statements. The typical if condition has an if block and an else block, and it looks something like this. So this is a pretty simple if-else block where I check if my age is greater than 18. If it is, then I set the status to be allowed. Otherwise, I set the status to be not allowed. So in Python, this exact scenario can be replicated in one single line of code as well. So let me just see the status over here right now. So as the age is 20, the status is allowed. Now if I want to write this in one line of code, it would go something like this. Let the age be 20, and then I set the status as not allowed, allowed, age greater than 18. So as the age is 20, the status should be set to allowed. And if I change the age to be say 12 and then I run that again, the status should be not allowed, and that is what we get. So let me take a moment to explain what's going on over here. So basically this is an array of two items. The first item is not allowed and the second item is allowed. Or in other words, the 0th index is not allowed and the first index is allowed. And what we do over here is we have a condition, right? So we have a condition saying age greater than 18. So when you execute this small segment of code, this would either return you a true or a false because it's a Boolean operator. So depending on whatever the outcome here is, it would be a true or a false. And since that is wrapped inside a list bracket, it would get typecasted to integer. So if the age is indeed greater than 18, it would return us a true, which would be typecasted to 1. So when we have the first index over here, it is like saying I want to index into this array with index 1. So the first index is allowed, so our status would be set to allowed. If this was false, this value would be typecasted to 0, and the 0th index of this array is not allowed, and that's why our status is also set to not allowed. I do agree that this is not perhaps the most cleanest way to write a one-liner if-else statement, and that's why we also have another syntax which is valid in Python. So we can say status is equal to allowed if age is greater than 18, else not allowed. So since our age is 12 right now, we have status is not allowed. If I change the age back to something else and run that again, our status would be allowed. So this syntax is a lot more cleaner to read and easier to understand. Number 8. Python debugger. Python has an excellent inbuilt debugger called PDB, which stands for Python debugger, and it proves to be really helpful while debugging large amounts of code. So for example, I have a small script over here which has initialized value 1 to be 2 and value 2 to be 20, and then we also have an empty list, and then we are making a simple for loop which iterates 5 times, and then we do some basic math, store it in R, and then append that result to the results list which we had initialized earlier. Now say we want to debug this small script, right? So we will import PDB, which is a part of the standard Python library, and wherever we want to start the debugging process, over there we will say pdb.setTrace. So what this will do is it will start the execution of the script like normal, and when it encounters this particular line of code, it will stop the execution and open up an interactive shell where we can interact with the code manually. Let's take a look. So when I ran that code, it executed all of the lines which occurred before this, and it halted over here and opened up an interactive shell. So we can interact with all our variables which we had defined earlier. So for example, let me just rearrange this. So up until this point, we should have a val1 defined, so we can check the value of val1. We can also check the value of val2, and then also results as well, which is an empty list, which makes sense. We can also check the value of I, which is right now 0, as this is the first iteration. Now we can say n to execute the next line of code. So we are appending results. We can check the value of r as well, so we can say print r. So r right now is 20. Let's execute the next line. The next line. So this is the second iteration. So the value of I is 1. And the next line, so we're appending it to r. So we can see what the results are. So right now the results list only contains 20, and then we execute the next line, and now results will also have the next result, which is 22. So as you can see, it allows us to interact with our code at a very minuscule level, so we can monitor every single line of code and see the intermediate values produced in real time. Number 9, adding progress bar to all of your loops. So there have been many times where I've wanted to add a progress bar to a loop which I've made, which runs for a long amount of time, so I can track its progress in real time. So there's this really neat library called todm, which is not a part of the standard Python library, but you can install it using pip. Now I can open up Python, and And now we can say from tqdm import tqdm, and I will also import time, and I will say for I in range, say let's say 10,000. So I want to do something 10,000 times, right? So I want to add a progress bar to this. So instead of saying for I in range of 10,000, I will simply say for I in range tqdm of range 10,000. So basically we are encompassing the iterable in this clause, which is range of 10,000. And let's say I just do a time dot sleep here of 0.1 seconds. And when we run this, we can see a neat little progress bar which arises here, which tells you the current iteration time. So we are currently at the 120th iteration, and you can also see the speed. So right now we are doing around 9 iterations per second, and the overall progress is 2%. So let me change some values over here. Let me make that 0.01. Now we can have a faster progress bar. Pretty printing your two-dimensional lists. A lot of times when we're coding, we have a two-dimensional list which we want to print out. And when we do print it out on the console, it looks really ugly, and it's generally difficult to read when the list gets really long. Enter tabulate. Tabulate is a small and really handy Python library which tabulates your two-dimensional data in a neat and table-like way. To install it, we can just say pip install tabulate. So now I will open up my Python shell and paste in some dummy data which I have created. So now when we just print the table out, we get this on our console output, which is not very readable. So now we can use tabulate. So we will import tabulate first, and we can simply say print tabulate of table. And as you can see, it prints out this entire two-dimensional list in a neat and readable way. Now there are tons of customizing options available as well. You can format your tables in different ways. You can even format it to HTML source code directly. Number 11, automating the keyboard. Using this trick, you can control your computer's keyboard and make it type whatever you want to, including complex combinations, large text, hotkeys, etc. For this, you'll need the keyboard module, which is available via pip. And after you have installed it, you can do something like this. You can import keyboard, and then you can say keyboard.write and whatever text which you want to type in. You can even say keyboard.press and release, and you can pass in a combination of keys or hotkeys like shift plus S and then press space. For more details about this module, you can go over to the link in the description, which has the entire documentation for this module. So I can come over to my terminal and say python type.py, which is the name of the script which I had made. And as soon as I press enter, I will focus my mouse on this sticky pad over here so that you can see the text output. So I'm going to press enter, and I'm pressing over here. And as you can see, it typed out that entire string automatically within no time. Number 12, make your standard Python shell better. So if you've been noticing, for the past couple of tricks, I've been using a custom Python shell which has a lot of enhancements over the standard one, and this shell is called ptpython. You can install it via pip and invoke it like so. So this gives you access to a normal Python shell but with a lot of batteries included. So for example, it has syntax highlighting. So I can say for I in range 10, and it will automatically highlight the keywords in that string. It also automatically indents, which the standard Python shell does not do. And what is more, when you press the up arrow, instead of going back to the last line, it goes back to the last clause. So if your previous clause was an entire block of for loop or an entire block of if else statements, it would copy that entire thing and not just the line, which is pretty neat, and you can even edit it over here. It also has an autocomplete feature. So if I have a string over here and if I do a dot, I can see all the methods which are available of the string data type. Also, if I import a module like say time, and then I do time dot, it gives me access to all the attributes and methods which that module has. So these are just a couple of things which ptpython has improved over the standard Python shell. I highly recommend you guys to try it out, and once you do, trust me, you will not go back to the old shell. So this was the last item of this video, and if you guys like the video, please do consider subscribing to my channel and drop a like and share the video. Thank you.